Hi everyone, welcome to our presentation on pandas. Sadly, we're not talking about these cute fluffy animals, but of course about the Python package called Pandas. It will make you ditch Excel for good because of its amazing qualities, and if you can't still believe it yet, just tag along. First things first, of course, you need to install Pandas in your environment if you're not working with Colab. We skip that step in this short introduction, but you will find very easy and short explanations on how to do that in the internet. And after installing the package, you then have to import Pandas. We demonstrate that in Colab. You do that just with the command import pandas as PD. Why as PD? You can use that as a shortcut for later reference to the package. So then when you call it, you just have to write PD and not pandas. So first step is already done. As I already said, pandas is great for working with data. And therefore, the next step, of course, is to get some data to work with. In this introduction, we're going to use the very famous or also infamous Titanic data. That's a data set that you will also find in a lot of other tutorials on pandas that are out there in the web. Little disclaimer, for simplicity, we're only going to show you how to import a data set of a CSV file, but of course, you can also import other file types. So for importing the data, you're going to give your data set a name. Ours is Titanic DF, and then you call from the pandas package the read CSV function, call the name of the file, in this case Titanic CSV, and decide on a column of your data set that should be the index column. We're choosing the first column, which is the passenger ID in the data set. Of course, it's Python, so we have to call the number 0 column. And also, little hint or explanation for simplicity, we already loaded the data set into Colab to easily call it with the read CSV function. If you now execute that function, what happens is that you import the data. Your imported data will be part of a table, or how you call it in pandas, a data frame. And this is the main object of pandas that you will work with most of the times. You can, of course, also create your own data frames out of series, and the series then will be, each series will be a column. Little info, what is great about pandas is that compared to other packages of in Python, each column of the data frame in pandas can have a different data type. So now we want to get like a feeling for the data we're going to work with, how to do that. What you can do is to start with the basic print function that you know and print the entire data set. Here you see, because in Colab the space that's being viewed is limited, you see the columns of the data set with the points. You see that there are more columns that are not shown. At the bottom, you see the number of rows and the number of columns that this data set has. If you think that this display is not really pretty, you could also decide to just show you parts of the data set. For example, you could decide to just get the head of the data set with the head function. It will only show you 5 rows, or of course, as well, you can use the tail function, which will show you the end of the data set. After the first sneak peek into your data set, maybe you want to get an actual overview. What you then could use is the function, the info function. If you do that, it also gives you the number of entries, the number of columns, and as you can see here, a summary of each column, the amount of non-null values in there, and the data type for each column as like a little summary. To dig a bit deeper into the data frame, what you can then do, for example, is use the df column to just get one column out of there. Here, for example, you could decide on the name column to see all the names of the passengers here, 1 to 891. Or what you can also do if you want to see single rows is use either the lock or the ilock function. The lock function, for example, is choosing the row depending on the column that you set as a primary key. Okay, so the second entry there is a full of NA. Let's take another one, third one. Here you see it's Miss Lena Heikkinen, yeah. Or what you can also do is not depending, like selecting on your index column, but on the position of the row. Here, if we type in ilog and, for example, select the second row, you will surprisingly see, even though we have a 3 here and a 2 here, that it's the same entry. And here again, hint Python, since your index is going to start counting at 0, and here it's the actual position of the row, 3 and 2 in this case give you the same result. If that's all too easy for you and you're like already bored to death, we have a little advanced function for you, and that is iterrows. If you use iterrow with a for loop, iterrows produces a list of tuples, and every tuple contains index and a dictionary, and like the corresponding dictionary contain all the information of the row. And then you have a list of for every row of that. So our function here prints, like makes row go through each of the tuples in the list, and this part tells it to look at the second element. Again, it's leading 0 and 1. So 1 is the second element of each tuple, and that's the dictionary. If you remember, each tuple has the index and a dictionary. So look at the dictionary, and the name tells it to look into the name element of that dictionary and print what's in there. So if we execute it at the end, you will get a list of all the names. And if you scroll here, you will actually see it's all the names, one by one in the result. So now, after getting a feeling for a data set, we maybe want to clean it. So in the next section, we show you some useful functions for cleaning data. First of all, always the very important question for a clean data set is if there are null values. There's, of course, a function to check for null values. You could use the isNull function, and that function will give you Boolean values for the question, whether in each row and column there's a missing value or not. What you then can do, for example, is the function drop_NA to get rid of all the missing values. Here you see that we only have now 182 rows. So you have to be careful with a drop_NA function because you can lose a lot of data with that. And you might want to think about which rows of the data set or which columns are important for you in your analysis and only clean those rows. In our case, we would have lost a lot of Titanic passengers and removed them from history books because we have a column cabin that has lots of NAs. On a second thought, so maybe you want to keep the missing values but replace them all with a certain value. You can do that with the fill NA function, and for example, put ABC, whatever, for all missing values. Now here see we have all the rows again, and for the cabin, a lot of ABCs. What you could also do is dropping single columns or rows. As we've already seen above, we have this second row, which is full of NAs. And of course, that has a reason because we want to practice with you. The function is the drop function. And here you have to be careful to decide whether we have to tell the drop function on which axis you want to drop something. So axis 0 will drop you a specific row. Here you see row 2 is missing. Or what you can also do to drop a column is use the drop function. And for example, we're going to, just for explanation reasons, drop the second column, which has the name survived, and then tell Python that we want to drop on the axis 1, which is the column axis. So here you're going to see the survived column is missing. So these are the basic cleaning functions, and let's continue with another set, and that's filter, sort, and group by. First, the filter function is a really intuitive one. For example, if we want to know how many people there were, or filter for senior passengers, we're gonna use just the print function and just print a subset of the data set. How we do that, we just gonna use in square brackets our data set and decide on, again, in square brackets, which column we want to subset. Let's take age and tell the function that we just want to have the age of only the people where the age is above 70. And here we see we only have 5 passengers that are over the age of 70. Also a nice function is the sorting. Here, for example, you can use the sort values function. Again, maybe to see if we know that there are only 5 passengers over 70, we can check that by also sorting now by age. The function, as I said, is sort values. And then you give it the by argument, the column you want to sort by. So we choose age. And then what you can do is decide whether you want to have it in ascending order or descending. So we want to have it in descending, and therefore we want to set the argument ascending to false. If we do that, we see here again, that can also be actually a little check that the oldest passenger was 80, and after that there are our 5 passengers from above, if you compare the passengers ID, which are above 70, as a little sanity check. Let's continue to the next nice function, that's grouping, or the function is group by. What could be interesting as an analysis is to see, as we can see here, we have 3 different classes, to group by class. And maybe also, if you want to know how many passengers were there per class, combine the group by function with the sum function. How are we going to do that? We're first going to call the group by function and tell it from which column we want to group by. So we take the p class function. Also group by that we want to have it by column. So we set the x's by to 0, or like it's grouping by like getting the rows together. And then after the group by, we add the sum function. So what you see as a result is first it grouped by the 3 classes and then summed up the number of rows you have for that group. So we see here, for example, for the survived variable, that makes sense. We have 135 people that survived the first class. Be careful, for example, for age, you see that it doesn't make any sense, 7,000 something. The sum function just really sums up all the values together. So it sums up all the age. Doesn't really make sense. So again, be careful for what it makes sense. And we are already now with summing up, we already go into the direction of statistics. So as a last set of nice functions from Pandas, we're going to show you some basic statistics functions. As we've already seen, group by can be combined with sum for some kind of questions we have. For other questions, a very useful function can be the counting function that we combine with group by. For example, we already know how many people survived in each class. Maybe we want to compare that with the amount of tickets that have been sold. So we need to count the tickets by class. And we do that with the function, so group by again by class, and then add count and the column ticket. And then we see the amount of tickets that have been sold and can compare that with the people survived by each class. And you see there was a best chance to survive if you have been in the first class. For a very quick overview of the summary statistics, at least for the numerical columns, you can use the describe function. What that gives you is an overview of the numerical columns, as I've said, and summary statistics like the count, the mean, standard deviation, or a minimum maximum. Of course, you can also use these functions one by one, and also just for single columns. For example, get the mean for the age. Here you see it's the same number as here in the summary table, or the minimum or the median. Coming to the end of our little presentation, you might also think now that taking a trip on the Titanic would be amazing, but of course you want to survive, and as we've already seen, people from the first class were way more likely to survive than other classes. So the question is, could we actually afford a first class ticket? If you have such questions, we know with the fare column of the old data set what the fare was back in 1912. And what we did for you is to get the average inflation of the British pound from 1912, and that was 4.47%. And maybe we want to include after the into our data set a new column that actually has the information on what the fare would be today. We can easily do that with Pandas, of course. How we do that? You take the data frame and choose the name of the new column that you want to add to it. And then just tell Pandas or Python from which old column you want to calculate the values of this one. So we take the Titanic fare column, so the existing fare column, and multiply it by the inflation rate to the power of the number of years. And to show you that this worked, we're going to ask for the head of the data set. And you see here, here's our old fare column, and here's our new fare column. And checking the new fare column, since we know that first-class passengers were most likely or more likely to survive, and if we now think of taking a Titanic trip today, we want to be in the first class, maybe as like the passenger 4 here, we would need to calculate with a fare or a ticket price of over 6,000 British pounds. So wisely calculate your risk if you want to take a trip. Otherwise, the Titanic would be ready to board for you now. To give you a little life insurance, we're sharing this cheat sheet for Pandas with you. It is a collection of a lot of functions that might come in handy while you use Pandas. Now, you don't need to rely on us. We took it from the official Pandas website, a source that we can recommend 100%. Also, if you want to dig deeper and go into more advanced functions. We will make the Colab file, the presentation, the data set, and also that cheat sheet and another one available in the chat to you. And also, as we said, the Titanic dataset is often used in a lot of other tutorials, so it's easy to find further corresponding examples. And lastly, as a little teaser, Pandas works beautifully with Matplotlib and NumPy, so stay tuned for those package presentations in next week as well. Thanks for tagging along. Cheers and see you around.